Welcome to our lesson on direction fields for first-order differential equations. These powerful visual tools help us understand the behavior of solutions to differential equations, even without solving them explicitly. A direction field, also called a slope field, is a graphical representation of a first-order differential equation of the form dy dx equals f of x, y. At each point, x, y, in the coordinate plane, we draw a small line segment whose slope equals f of x, y. By looking at the pattern of these small line segments, or tick marks, we can visualize how solution curves must flow through the field. Let's see what this means with a simple example. Let's focus on our first example, the differential equation dy dx equals negative 2y. This is a simple separable equation where the slope at any point, x, y, depends only on the y-coordinate, not on x. Let's create the direction field for this equation. Notice some key patterns. First, when y is positive, dy dx is negative, so all the ticks point downward. Second, when y is negative, dy dx is positive, so all the ticks point upward. And third, the farther you are from the x-axis, where y equals 0, the steeper the ticks become. Looking at this direction field, we can see how solution curves must flow. The solutions exponentially decay toward the x-axis as x increases. This matches exactly with the general solution, y equals c times e to the negative 2x, which approaches 0 as x approaches positive infinity for any constant c. Now let's examine our second example, dy dx equals negative y over x. This is another separable equation, but here the slope at any point, x, y, depends on the ratio of y to x. Let's create the direction field for this equation. Notice two important patterns. First, along any ray from the origin, where the ratio y over x is constant, all the ticks have the same slope. Second, if you move along a given hyperbola y equals k times x, then dy dx equals negative k is constant. Looking at this direction field, we can visualize the solution curves. The solutions are of the form y equals c over x, which are hyperbolas with the x and y-axis as asymptotes. We can derive this by separating variables. Integrating dy over y equals negative dx over x gives us natural log of absolute y equals negative natural log of absolute x plus natural log of absolute c, which simplifies to y equals c over x. Direction fields are powerful tools because they let us understand qualitative behavior of solutions without actually solving the differential equation. From the direction field, we can easily see where solutions are increasing, where they're decreasing, and how steeply they climb or fall. To summarize, direction fields provide a visual representation of a differential equation's behavior. By plotting enough little slopes, we can connect the dots visually and see the qualitative behavior of every solution without solving the equation explicitly. This is particularly valuable when dealing with differential equations that are difficult or impossible to solve analytically.